In this last lesson of this unit, we are going to see how to obtain the quadratic equation by looking at the graph. But first of all, let's remember how we can write quadratic equations or functions. They can be written in one of three ways. You can have f of x equals ax squared plus bx plus c, and this is the general form. You can have it written as a times x minus p times x minus q, which is the factorized form, and of course this implies that the quadratic is factorizable. And the third form is the vertex form, a times x minus h all squared plus k. Now each of these forms gives us something. In all cases, a tells us about the concavity. If a is positive, the parabola is concave up. If it's negative, the parabola is concave down. In this case, the general form, the y-intercept is at 0c. In the factorized form, we have roots at x equals p and q. And in the vertex form, we know that the coordinates of the vertex are h, k. So in order to find the equation of a quadratic by looking at the graph, we have to see what information is given on the graph, and we can choose the most appropriate form to work with. Let's look at some examples. If, for example, we have this curve, this parabola, and we know that this equation is function of x is ax squared minus 8x plus 96. And we want to find the value of a and the two roots. In this case, we know that the axis of symmetry is at -1, which is the x-coordinate of the vertex. And we know that the x-coordinate of the vertex is given by -b over 2a. And this equals, obviously, -1. Substituting for b, negative of -8 is 8, divided by 2a gives us -1, and this implies that a is a negative value, of course, and it's -4. Actually, if you get a positive value for a, you should check your work, because obviously the parabola is concave down, so a must be negative. Having done this, you already know that a is -4, so your expression becomes -4x squared minus 8x plus 96. And in order to find the two roots, you set it equal to 0. You take a -4 as a common factor, leaving you with x squared plus 2x minus 24 equals 0. This is easy to factorize. -4 times x plus 6 times x minus 4 equals 0. And obviously, you have two solutions. The two roots are x equals -6 or 4. So this will be -6, this will be 4. And you're done. In this next example, we want to find the equation of the quadratic. What we have is the value of the two roots plus the y-intercept. And since we have the value of the two roots, I would go immediately for the factorized form. So I would be working with f of x equals a times x minus 1, the first root, x minus 1, times x plus 3, which is the second factor that corresponds to the second root. Now, we don't know what the value of a is, but we have an extra piece of information, which is the y-intercept. The y-intercept occurs at x equals 0. So f of 0 equals negative 12 from the graph, and this equals a times 0 minus 1 is negative 1, 0 plus 3 is 3. So what we have here is negative 12 equals negative 3a. And this leads to a equals 4. And you're done. You have your quadratic. And it can be written as f of x equals 4 times x minus 1 times x plus 3. And you can factorize it if you wish. I mean, you can expand it to write it in the general form. Another example is a parabola that's concave down, and we have loads of information. We have the two roots, and we have the coordinates of the vertex. So if we start with the factorized form, f of x is equal to a times x plus 2, which is the factor that corresponds to the first root, times x minus 6, which is the factor that corresponds to the second root. And then what we know is that at the point where x equals 2, y equals 16. So f of 2 equals 16, and this equals a times, substituting x equals 2 times 4, and if you substitute x equals 2 in this bracket, 2 minus 6 is negative 4. This gives us 16 equals negative 16a, thus a is negative 1. So your function is negative x plus 2 times x minus 6. Now, this is one method. Another method would be to start with focusing on the vertex. So you would say, okay, I will start with f of x is equal to the vertex form a times x minus h all squared plus k, and the coordinates of the vertex are 2, 16, so this leads us to a times x minus 2 all squared plus 16. Now, we have two other pieces of information, the first root and the second root. So we know that f of 6 equals 0, which is this point right here. So substituting 6 for x, we get a times 6 minus 2 is 4 squared plus 16. So this is 16a plus 16 equals 0. And obviously, a equals -1. So your other form can be f of x is equal to negative x minus 2 whole squared plus 16. And if you expand this, the factorized form, and expand the vertex form, you'll find that they end up as exactly the same thing. Again, in this example, we have only one root, the x-coordinate of the vertex, and the y-intercept. So, which is it? If you remember, the axis of symmetry lies exactly in the middle between the two roots. So we can work out the value of the second root. Let's call the second root q. In this case, the sum of the two roots divided by 2 will give you the midpoint. So q minus 4 divided by 2 is equal to -1. Cross multiply gives you q minus 4 equals -2. So q equals 2. So now you have the two roots. And it seems logical to go to the factorized form. So our factorized form is f of x is equal to a times the first factor is x plus 4, which corresponds to the first root, and the second factor is x minus 2, which corresponds to the second root. Now we know that f of 0 is -12. And this equals a times 0 plus 4 is 4, 0 minus 2 is -2, and this gives us -12 is equal to minus 6a, and a is therefore equal to 2. So your quadratic is f of x is equal to 2 times x plus 4 times x minus 2. And our final example is probably the easiest. Immediately, as soon as you see a curve of a parabola making a tangent with the x-axis, you know that it is a perfect square. So we know we're dealing with something of this form. F of x is equal to a times x minus p whole squared. And immediately you can decide that the value of p, which is the root, is -2. This is given on the graph. So this is a times x plus 2 whole squared. Now you know that a is going to be negative because the parabola is concave down. And you know that f of 0, the y-intercept, is -10. And this is equal to a times, when x is 0, this bracket simplifies to 2 squared. So 4a equals -10, and therefore a equals -2.5. So the quadratic is f of x is equal to -2.5 times x plus 2 whole squared. And this part is the perfect square. I mean, forget this constant. There is a repeated factor. That's what matters in this case.